Okay, so now we're going to tackle dividing rational expressions. So you're going to do everything exactly the same as you would do if you were going to multiply them, except for the two highlighted steps. So if you kind of remember back when you were in 5th grade or whenever you learned your fractions, let's say I wanted to take 3 over 4 and I wanted to divide that by 1/2, okay? So dividing by 1/2, what you were probably taught was that you needed to change that into multiplication. So whatever you're dividing by, you would actually multiply by its reciprocal. So I am dividing by 1/2, so I would only find the reciprocal of 1/2, not 3 over 4. So a common mistake would be people like flipping that first section there. You don't do that. So you're going to keep it 3 over 4, and then you're going to multiply by the reciprocal of what you're dividing by. So that'd be 2 over 1, and then you can kind of look at it after you after you change it to multiplication, then you can start reducing. So that 2 is going to reduce with a 4, and then that's going to leave me 3 over 2. Okay, so you're going to have the same process here, and if you notice, I put in highlighter, you're going to change division into multiplication, basically just multiply by the reciprocal of whatever you're dividing by. Then you're going to have to recheck for your undefined values. So the reason why we have to recheck is when you write down the reciprocal, you have a new denominator. So at any point in your problem, when you're working it out, anything in the denominator could possibly create a value of 0 needs to be noted. So you're going to have to check for your undefined values twice. All right, so let's look at this example. So number 1, you're going to factor everything like you normally would. Check for your undefined values. So right here, these x's, they can't be equal to 0. This can't be equal to -2, and this one can't be equal to +1. So right now I have 3 undefined values. Then what we're going to do is we're going to change this into multiplication. So we're going to swap the numerator and the denominator, and it has created a new denominator. So x plus 2 is already in your denominator, so that's not a new value, but the x plus 7, x can't be -7, so you got to be really careful about that. Then you go back to your normal thing. You're just going to have fun canceling out all your common factors, and then you just kind of write down what you have left over, okay? So you just have those 2 extra steps, and then you're good to go. So let's do number 1. Okay, so the first thing we want to do is we're going to factor. I think I'm just going to rewrite it over here to the side. So 6x, if you want to break down the 6, you can. You don't have to. I'm going to put 2 times 3 times x. This one has a GCF of 3. Okay, the top one over here has a GCF of 9. But I'm still not done factoring, so this is a 2-step right here. So if I was going to factor above it, I need to find the factors of -4 that add up to be -3. So that's going to be -4 and +1. Okay, I'm going to get rid of that. I don't want it complicating my visual field here. So then I'm going to take a GCF here of x, and that's going to leave me x minus 10. Okay. So I didn't do the whole multiply by the reciprocal thing yet because I need to check for undefined values. So this 3 here is safe because it does not have an x, but this x is a problem. So this x cannot be a 10. This x cannot be 0. And this x also cannot be a 10. So I already have that written down, so I'm not worried about it. Now I get to do the reciprocal. So I'm going to put 2 times 3 times x. Only write the reciprocal of what you're dividing by. So I'm going to put x minus 10 on the top. Now remember, when you're writing down this new denominator, it may create new undefined values. So let's see here. That cannot be 4. So this is a new undefined value. Cannot be positive 4. And this x cannot be negative 1. This 9 is not a problem because it's not a variable. It's not going to create a 0. It's 9. All right, now here's the fun part. Look at your monomials. Do you have any monomials that will cancel with any other monomials? Yes, we do. That 3 is going to reduce with that 3. But that's it. Everything else is in the numerator. I can't cancel anything. Binomials that will cancel out. X minus 10 and x minus 10. Okay, so just do a quick double check. Make sure you have your monomials covered and then your binomials. I'm going to simplify monomials. So 2 times x is 2x squared. And then that 9's going to hang out. So is x minus 4 and x plus 1. Final answer. All right, it's time for our challenge problem of the day. So what we want to do here is recognize the fact that the first two fractions are being multiplied, but the third one is being divided. So as I rewrite this, let's consider that. So this first part, it's going to be x minus 6, x minus 8. This one's going to be x minus 2, x plus 1. Top part's going to be 4 plus x, that's a difference of squares, 4 minus x. Bottom, x, gotta think about it, minus 6x plus 2. Okay, now this one right here, we gotta be really careful. So I'm gonna write it in blue above it. So that'll be x plus 9, x minus 8, and then x plus 1, x plus 9. So the reason why I'm doing that is I want to make sure that I'm gonna write down all of my excluded values first. So x cannot be equal to 2, or negative 1, or positive 6, negative 2. So in the blue ones, negative 1, I already have that one written down, and negative 9. All right, so that's a lot of excluded values. So what I'm going to do now in orange is I'm going to multiply by the reciprocal and just do a little flip-flop real quick. And just check and see if I have any additional excluded values. That one's already included. This one is not. So I have a grand total of 6 excluded values in this challenge problem. All right, so let's look for things that are exactly the same right now. I'm going to highlight. So x minus 6. Let's see, x minus 8. I have x plus 9s. Don't see, yep, I do. X plus 1. Okay, so what do I have left? So everything that blue is going to cancel out, and I have 4 plus x, 4 minus x, and then I have x minus 2, x plus 2. Now it's a little odd, the top, see how it's not written in standard form? If these were x plus or minus 4, then what you could do is you could take out a GCF of negative 1, change the signs, and eliminate. But since that's a 4 and that's a 2, really can't do anything about that. So that is my final answer.